All right, welcome to lesson 5.3 in text processing analysis. We're going to look at how to normalize counts of words in large amounts of text. All right, so the objective is that students will be capable of producing normalized counts of specific linguistic features in text files. Okay, so to take an example here, just to explain the idea of why you should normalize counts. If you're going to try and compare frequencies across two different books or two different corpora. I guess I'll just try and explain it right in here. Let's say we have a corpus A that has, I don't know, 10,000 words. Okay, and corpus B has, say, 5,000 words. Okay, so a corpus is a collection of text. Okay, so corpus A is twice as large as corpus B. And let's say we're looking for the word handsome in those two corpora. And we find that the word handsome occurs in corpus A, occurs, let's say, 25 times. And in corpus B, it occurs 30 times. Now let me think through this real quick. Now let's do it. I can do it the other way around. Okay, so let's do it this way. Let's say in corpus A we find the word handsome 30 times, and in corpus B we find it only 25 times. And so you ask the question, okay, which corpus has handsome more? Well, the answer is corpus A, right? Because 30 is larger than 25. But if we were to say, okay, but what about per million words or per 1,000 words per capita, right? Per million words, which corpus has handsome more frequently, right? And that's where we'd have to do a little bit of math. We have to say, okay, 30 hits in corpus A divided by 10,000 is, I'm going to have to real quick. I can't do it off the top of my head real quick. I think it's 333.3333. Let me double check that real quick. Pretty sure that's the case, but let me just do this. Right, not thinking clear there. So it's 0.003, right? So 3 out of 1,000 times, right? That's in corpus A. That's corpus A. Corpus B, what is the frequency per million or whatever number we need here? So we need 25 divided by 5,000, right? So 25 divided by 5,000 is equal to 0.005. Oh, 0.005. 25 divided by 5,000 is equal to 0.005. So now we see, actually in corpus B, per n number of words, per 1,000 words, per million words, doesn't really matter what base number we use. It's actually more frequent or more likely to occur in corpus B than in corpus A. The only way we know that is because we have to normalize it. We have to say, okay, how many words are there in corpus A? How many times does it occur? And we get a ratio. The ratio here of that 30 divided by 10,000 is 0.003. We do the same thing for corpus B. We found 25 occurrences of handsome in corpus B. There are 5,000 total words in corpus B. We get that ratio, and that's actually a higher ratio than corpus A. So you can't just look at raw numbers when you compare frequency counts across corpora or across novels or across any text, unless the two corpora or the two texts or the two novels have exactly down to the exact number of same number of words, which is very unlikely, right? So you have to normalize your counts so you can compare compare numbers across corpora. Right, so the way to do that, let's say we want to normalize this to, I don't know, 1 million words. So let's do 0.003 times a million. Then we get 3,000. So per million words, we get 3,000 occurrences, 3,000 per million words in corpus A, right? And if we do the same thing for corpus B, we get 5,000 words. So per million words, we get 5,000 on average occurrences of handsome, corpus B. Okay, so there's the reason that we need to normalize counts across corpora in order to compare number of occurrences. You cannot, once again, you cannot use raw numbers, raw frequency counts, unless by chance, some weird wild chance, the corpora had the exact same number, down to the exact number of words, which, right, never occurs, or rarely ever occurs. So you have to normalize. And mathematically, it's simple, right? You take the number of occurrences, divide by the number of times the number of words in the corpus or the text or the novel, and then you times it by some base number. We decided to go per million. So we took this ratio, times it by per million, and we say, okay, 3,000 per million words is how often handsome occurs in corpus A, whereas in corpus B, it actually occurs 5,000 times per million words in corpus B. So handsome is more frequent or more likely to occur in corpus B than corpus A. So that is the rationale for normalizing counts. All right, so how to do this in Python. The logic is not too bad. It's a little bit more involved, but not too scary. Right, so we first navigate to the directory with files and get their names. Pretty straightforward, right? We know how to navigate to a directory with the OS module in the chdir, change directory function. We create two collector variables. One for the total number of words in the file, and one for the number of matches of the desired linguistic feature. So in this case, we're looking at handsome, right? So we have two variables. We start them out as 0, and then we loop over the files. And as we're in each file, we split the current file into words. Then we loop over each of the words. And every time we look at a new word, we increment the total word counter. That is, we say, oh, here's another word. So we need to increase the total number of words of this file. And then we check if the current word matches a regex of some sort, or the word that we're looking for, like handsome or any form of handsome. And if that is so, if that evaluates to true, then we increment that, which means push up by 1, add 1 to the linguistic feature counter or collector. These should be called counters, really. I'm just going to call this counters. These are actually counters. Okay, then we increment this counter, the total word counter, by 1, and we increment the linguistic feature counter by 1. And after the loop is finished, after we've gone through every last word of all the words in the file, and we've incremented the total number counter every time, and we've only incremented the linguistic feature counter if the current word was one of the linguistic features. After that's all done, we divide the linguistic feature counter by the total words counter to create it's a ratio, actually, not a percentage, a ratio. Then we multiply that ratio by the base of the normalized count. For example, per 1,000 words, or per 10,000 words, or per million words, whatever, whatever you want to base it to. And then you print out the results to the screen, or you print them out to an output file, which we saw how to do that, right? We saw how to produce, push out to a file. Okay, so the logic is not too bad. Once again, the rationale is that you can't compare raw counts across corpora or across files unless by some weird chance they have the exact same number of words, which is not hardly ever the case, right? Okay, and Then you get a ratio and you times it by the base number, like per million, for example, million, to get the count per million number, which you can then compare across across the two corp or the two files. All right, so let's try this. From the Gutenberg project, download several TXT files of novels from an author of your choice. I'll just real quick show you what I'm talking about with that. Gutenberg project Gutenberg, I think that's what it's called. Yeah, Project Gutenberg. These have, there's a bunch of free e-files here, free ebooks. So they've changed the interface a bit since the last time I looked at it. But if I just come up here and say like Pride and Prejudice, there we have Pride and Prejudice. Okay. So you could click in here and you're going to look for the TXT or the plain text UTF-8. This is the one you want to find. Look for plain text UTF-8 rather than something else. You have all sorts of other things in here. You have HTML, EPUB, Kindle, and more files. Just look for the plain text UTF-8. That's what we want. So download that. There's a couple ways you could download that. You can right click on the link and do save link as, or you could click into the file and you're looking at a TXT file. Look at the URL right there. You could save this with like Control S on your keyboard. And to save it out, I'd probably change that to like Pride and Prejudice or just Pride to make sure you remember what that is. You can right click here and do save as well. Same idea, same result. So download a couple files from an author. So like grab Pride and Prejudice and maybe, let me just search for Jane Austen. Jane Austen. Maybe grab Pride and Prejudice and Emma and Sense and Sensibility, for example. Okay. And then after you do that, you're going to write a program to get a count normalized to 1,000 words, so a base of 1,000 words for a regex of your choice in one of the files. Then write the output to a CSV file, specifying that the columns be separated with a tab, that the rows be separated with a new line break. Import the output CSV file into a spreadsheet, for example, Excel, Google Spreadsheet, LibreOffice, Calc of your choice. Okay, so this should take a while. This may take a bit of time, but you have all the tools you need to do it now. Okay, so once again, the logic is that you're going to need to get the total number of words in each file, and then the total number, the number of linguistic features, the number of the linguistic feature that you're searching for. If you want to start with like handsome, just to make it simple, that's totally fine. And then you take the ratio and you times it by the base number, which I tell you here should be 1,000 in this exercise. Okay, so pause the video and see if you can do this. Take a few minutes or more, 10, 15 minutes to try and get this working. All right, let's see how we did this, how it went. So let me get over to PyCharm and grab this. That's what I have right there, but okay. So what we're going to do is we're looking for, I downloaded 6 novels from Jane Austen for another class I teach, and I use Jane Austen's novels for some analyses. So I have them on my hard drive already in a different folder, and here it is. I have 6 novels by Jane Austen: Pride and Prejudice, Sense and Sensibility, Persuasion, Northanger Abbey, Mansfield Park, and Emma. And I just simply got the TXT file. You can see here that they all have TXT at the end, like that. There's some extraneous stuff in here. If you want to get really technical, you could and should erase this like header from the Gutenberg project, Project Gutenberg. And the footer, there's a footer down at the very bottom as well. Anyway, there's a footer down there you can erase, but you don't really need to for this exercise. But if you're doing like for a final project or for something that's important, then you should delete that extraneous stuff. So the regex I wanted to find was all forms of handsome, not just the word handsome, but also handsomest, handsomer, handsomely, anything that starts with those 8 letters and anything else that comes after it. Okay. So let's walk through the code here a bit. On line 10, I import RE, which is a module that we'll need to do regex search. On line 11, I create a counter for the feature that is handsome or one of its forms. And then line 12 creates a counter for the total number of words in each file. In this one file, we'll start with just one file. Line 13, I open up a connection to Pride and Prejudice, excuse me, prideandprejudice.txt. There. And I just give the full pathway from the top of the file system on my computer all the way down to the file. You could do an OS and .change directory into that directory, Jane Austen, if you wanted to. Or you can just give the full pathway right here when you ask it to open it up. As a variable name, I'll just say fin for file in. Then I'm going to loop over each line. Now, these are paragraphs. These are hard returns. So it's a little bit misleading to say line because it's not a visual line. It's actually just as many lines as you need to get to the next hard return, which could be one visual line or many, right? So in files, when I say line, I'm referring to a hard return. Okay, we're gonna go over each line. Then we're gonna split up each line into words by doing a re.split. I'm giving it this regex right here. Okay, regex is coming up all the time in text processing. Once again, we have an R before the double opening quote. Then we have a character class between square brackets. We have a caret, which means not one of these characters. So I don't want it to split up on a dash, nor a single apostrophe. So it doesn't split up on can't or wouldn't, right? Anything that has an apostrophe in the word, nor on A through Z. So I don't want it to split up on letters, nor apostrophes, nor dashes, right? Because we have, in English, we have words that have a dash and an apostrophe right in the middle of the word. So find something besides those things. That's what the caret says, right? Something besides one of these things in here, one or more times on the current line. Don't worry about case on the A through Z. And once we have a list, right, it returns a list of words. We're going to loop over those words in that list one at a time. The first thing we do is we always increment the, this right here gets rid of empty elements in the list. Like we've seen in the past, when you split up, you can get empty elements. Sometimes if you have like two separators right next to each other, or if there's a separator at the end of the word, the end of the string, it could leave an empty element at the end. So we get rid of that there. If the length of word is greater than 0, then we want to increase the total count, right? This total count is for all the words in the current file. So we increment it by 1. This, once again, this plus equals is a shorthand for a more verbose form, which is count total equals count total plus 1, meaning take the current count, add 1 to it, and save it back to itself. And this is shorthand for that. And then we search for this regex in the current word. Okay, we say we want to find a word boundary. Then we want to find handsome, those 8 letters. Then we want to find \w, which is, remember that? \lowercase w is alphanumeric character, followed by an asterisk, which means 1 or more times, excuse me, 0 or more times, 0 or more times. So we could find the word handsome, and we will find handsomer, handsomest, handsomely, etc. And if we do that, if we do find, if the current word has this regex in it, meaning it's a form of handsome, then we want to increment, that is add 1 to the current count for the feature. In this case, the feature is handsome, or one of its derived forms. Okay, so that's the logic of it. And then once all of that has run, so let me scroll this down a bit so we can look at this a bit. So the fact that line 23 is indented at the same level as line 14 means that line 14 through 20 will finish running before we run line 21, which means that it'll go through all the lines in the novel, and within each line, it'll go through all the words. Okay. Once it's done doing that, then we just do simple math. The count of the feature, in this case, handsome, divided by the count of the total number of words times 100. That's 1,000,000. My word. That's 1,000 there. So count of feature divided by the count of total times 1,000. All right. So now as division and multiplication on the same level of order of operations, it'll do this first. It'll divide that first, and then it'll take the result and times it by 1,000. Okay. Good. Then, so that's the simple math, right? And then down here on 24 through 26, we actually write out to a CSV file. And here we do open, right? With open, we're going to create a file called results.csv there. And we need to say W here, mode equals W. We could actually specify this is the mode. We don't have to because that's the second argument in the call to open. As a variable name, and then here's the variable name again, fout.write. And here's a header. I'm just simply putting a header. The first row is going to be feature, tab, norm, count, 1,000, new line break. New line break. So \T creates a tab, \N creates a new line break. And then after that, we want to write out handsome and derived forms, tab. Then we do plus sign to concatenate this string to this norm count that we calculated on 23. We have to push it to a string because it's a number, it's a float, right? We have to change it to a string so that it will concatenate correctly with this other string over here and this other one over here. And then we do plus sign new line break. Okay. So let me run this and see what happens. Okay, I think it should have run correctly. Let's see if over my downloads, I told to put results into downloads. Right here is downloads. I'm going to grab this and open it up in Excel. See what happens here. Okay, I did it correctly, but it didn't import it correctly into Excel. So Python worked correctly, but it didn't import correctly over here. Yeah, so the reason is because we're using tabs here. Back over here, we're saying, hey, use the tab separator here and here. So we could solve this a couple ways. One, we could actually do an import. I'm going to shut this down, and then I'm going to do new command N and have a new spreadsheet. Then go up to data, the data tab in Excel. It's the sixth one over from left. Go to from text, the second icon there, from text. It may not be the exact second, it may not be the second icon from the left on your version of Excel, but somewhere here in data, there should be something from text, import from text or something like that. And then downloads, results.csv there. And delimited, yep. Click next, and there it says, yeah, the tab is the separator. At this point, I can just push finish and say, yeah, put it in A1. There we go. Okay, so apparently handsome or one of its derived forms occurs only 0.367 times per 1,000 words in Pride and Prejudice. In this case, it might be more useful to make the base number 10,000 rather than 1,000 so that we get 3.67 times per 10,000 words. But anyway, so that's how many words or how many times per 1,000 words handsome or one of its derived forms occurs in Pride and Prejudice. By derived forms, I mean forms that are derived from handsome, like handsomely, handsomest, handsomer, any others that may start with handsome. Okay. So let me jump back over to this code. If you like to look at the code or look at the solution file, the code itself is not too long, not too bad. If you want to make this work on your end, you can look at the solution file, or yeah, it's probably best to look at the solution file. Okay, if you want to pause the video, make it work now, it'd be good. Okay, modify the program to get normalized counts for each of the novels you downloaded. Modify the code that produces the output CSV file so that it is easy to compare the normalized counts across the novels. Okay, so now we need to go through all 6, in my case, it would be 6 novels because I have 6 files that I downloaded, right? If you only downloaded 2 or 3, then you only have 2 or 3 files to deal with. But you're going to want to loop over those files. You're not going to want to do this. You're not going to want to copy and paste big chunks of code. You just want to put it into a for loop that loops over those 6 files. So give it a try. See if you can do something that does this. Once again, you get normalized counts for the linguistic feature of your choice. In my case, it was handsome in one of the derived forms. And you're going to do it for each of the novels, not just the one novel. Okay, so pause the video and give it a try. Okay, let's take a look. This is more involved. Admittedly, this one's more involved because you have to deal with 6 or n number of novels, not just one. But it's still not too onerous. Let's just walk through the code and look at it. Still not too tough. Okay, in this case, I'm going to see change directory, CD, I almost said, but change directory in Python into the directory that has those 6 txt files. So let me flip back over to Finder, show you what I'm talking about again. So within my LING 3, it's actually 240. That's where I have those files. Jane Austen. I have 6 txt files, and they are the 6 novels that I downloaded from Project Gutenberg, and they're each a txt file. So I'm navigating into this directory called Jane Austen. That's the first thing I do on line 3. Okay, then I get the file names. I just want to see the file names. And so I do this with the list comprehension. I'll just go ahead and do F for file in here. You can do any variable name, right? F may be more transparent. This is list comprehension. I say F for F in everything that's in the current directory, because os.listdir brings in the current directory, everything that's in the current directory. But then I say only if you find this regex. This regex says, I want to find an actual period, then I want to find txt, and this $sign is the end of string. And at the end of the file name, we want to find txt. That's what that $sign means. It's not looking for a $sign. That's a special character in regex, which means at the end of a string. So it's like a word boundary where it's not actually searching for any character. It's just looking for a word boundary that's actually a 0 width character. You might think of it as that way. And this $sign is the same way. It says end of character or end of string, not end of word, but end of string. Okay, so that should give me the file names. If we want, I'll just go and print this out, kind of walk through it slowly. I'm going to print out file names there. Raise exception, stop. Let me see if that works. Let me just run the script and see if it'll stop at that point for us. Stop. I forgot something there. Well, no matter. It's all right. I'm missing something there. I think it's what I'm trying to do is I'm trying to walk through it like line by line. We just let it run the whole way through, and it should print out the file names for us. There they are. So it prints out a list of the file names, those six novels that are sick, man. They're great novels. And so then I create a string that holds a variable output file. I'm just call it results CSV. I'm gonna put it in my downloads directory. Then I open an out file to that variable. I could just have put that right in, but it is better. I think it's better to put into a variable there. And then I'm going to write it out, save it as a variable there, right? F out. And then I'm going to write out the header. I'm going to say features in column 1. And then we have a tab. Then we have novel. Then we have a tab. Then we have norm count per 1,000 words. And then a new line break, \n. Okay. That's just the header. Then after we put that header into that output file, we're going to loop over the novels. So I'm going to loop over the file names, which was created up here, right? And so novel will hold the first novel during the first pass through the for loop. During the second pass, it'll hold the second novel, right? So I can just show this. I'll just go ahead and say print out for me novel at the moment. And let me run the whole script and let it just do the whole thing again. It'll be pretty quick. There's Manfield Park, Sense Sensibility. Now it's on to North Dagger, and then almost done. Pride and Prejudice, boom, done. So it went through those 6 novels that quickly. And every time it came to a new novel, it printed out because of my line 11 there. That was just a little debugging thing, or just so I can see what it's doing. Okay, so when we come into a new novel, we need to create 2 counters, and we need to zero them out to 0, right? We need to put them back to 0. So I say count feature equals 0, count total equals 0. Then we open up the current novel, right, which is passed in through here to this for loop, right? And it's looping over this list. So during the first pass, it will have the first novel. So it'll say Mansfield Park.txt. It's not alphabetized because it doesn't automatically alphabetize. You could sort it if you want before you do this, but it's not a big deal. Okay, so we open up the first novel, or the current novel that is, depending on what iteration we're in the for loop. And then we're gonna loop over that file connection and loop over each line in the file, right? Then we're gonna split up each line into words with this line 16, where we use re.split. We're using the same regex as before, so I won't take time to explain it in detail there. Well, it'll be good. It'll be good. So character class, square brackets, right? Then caret means not one of these symbols. So something other than these symbols, that is a dash, apostrophe, a single apostrophe for contractions, and A through Z. So something that's not one of those things, one or more times, that's what I want you to split up on. So it should split up on white space, on punctuation, anything that's not one of those, not a word character, right? Okay. Then, so we have a list of words in the current line in the current novel. Now let's loop over that list of words, which we'd start on line 17, for word in words, right? Because words holds the list of words. I'm going to choose the variable name word there. And then again, I deal with perhaps empty elements, empty strings, by saying if the length of the current word is greater than 1, then let's do something. If not, then don't worry about it. Just move on to the next one. So the first thing I do is I increment, which means increase by 1, the count total counter. So we need to know the total number of words to do the math later. And good. Then I say, if you find this regex in the current word, then increment the count feature by 1. So we found another instance of handsome. Okay. So it'll run through all the words in all the lines of the current novel. And then, so this right here, let me just point out, line 24, norm count is lined up with line 15. See that? Which means it'll run through all the lines, and within each line, it'll run through all the words. So it'll finish all the lines of the current novel. When that's done, we don't want it farther back than that. We don't want it over here because that would redo it every novel, but we want to save the information from the current novel and push it out to the CSV. So we let the for loop over the lines finish here. Then we do the simple math, count feature divided by count total times 1,000, right? Say that to a variable. And then we output the output string here. We concatenate the strings into an output string. We say handsome and derived forms tab plus OS path base name novel. So I'm taking just the file name, not the whole pathway from the top of my file system. I don't want all of that. I just want the file name, just the mansfieldpark.txt, etc. Divide that, separate that by a tab, plus sign, concatenate with string on the next string. Then we need to make a string version of that norm count by pushing it to string with that str function. And then we put a new line break. So that creates the output string. And then here on fout, which again, I'll jump back up and show you where fout is created. Fout is created right there on line 8. All right, we open up a connection to the out file and we save that connection object or that file object as fout for file out. And we write out to it the output string that we just created. Okay, so, and that just stays open. That out file connection just stays open until it's gone through all 6 novels. So let me run this. And I need to shut that down. Don't save. Let me go see if it's done over here. Did it finish? Let me run this again. Run that whole thing. There, print out all 6 novels. Now it's printing out each one as it's going through each one at a time. Persuasion to Emma, Pride and Prejudice. Done. I didn't say it to, I didn't have it tell me done, but this message right here is a PyCharm thing, so it tells me that it's done. Okay, so I should have in my downloads folder a CSV file called results. So let me see if that's the case. I'll just come over here. You know what I'm gonna do? I'm just gonna import it. I'm gonna come over to Excel, create a new file, new workbook with new, and then I'll come up to data, from text, go to my downloads, look for results.txt, no, CSV, results CSV right there. And then say next, make sure it says tab. Yep, that's correct. I'll just push finish now. Put it in A1, that's fine. And let's see what we got. All right, so it looks like North Angler Abbey has the highest per 1,000 word count of handsomer, one of its forms, in comparison to the other novels. And it looks like Mansfield Park at 0.20 has the lowest count per 1,000 words of the word handsome or its derived forms. And Pride and Prejudice is pretty high there at 0.36. And North Angler Abbey was at 0.41. Round up. Okay, so that's how you can compare between novels or corpora or anything. You have to, once again, normalize it to a common base number, like 1,000. All right, let's see. You know, just for fun, let me put in something here that we know is going to be much higher in one book than another. So let me just change handsome here for the moment to like Wickham. Is it Wickman or Wickham? I'm not totally sure. Let me try Mr. Wickham. Or Jane. How about Jane? I know Jane. How to spell Jane? How about that? So let me run that again. Run this whole thing. Let me shut this down over here. All right, it's going through Persuasion, Emma, Pride and Prejudice, done. Let me do the same import thing over here. Data from text results. I bet if I just push finish now, it'd be fine. Let's take a look. Yep, wouldn't you know it, the word Jane occurs 2.4 times per thousand words in Pride and Prejudice, 1.9 times per thousand words in Emma, and very little in any other novel. That's what we would expect, right? Jane is a character in Pride and Prejudice that is very prominent in that novel. Elizabeth would be even higher. All right, so that's the idea. The idea is not hard to understand, right? You simply go through and normalize to a common base number. Okay, next one's a little, let's ramp it up. Let's ramp things up, which says download several TXT files from another author, modify your program to get normalized counts for each novel. Again, modify the code that produces the output CSV to make it easy to compare the normalized counts across the novels by letting us know what novel it comes from and what feature it is. Okay. So give that a try. Download some more TXT files from like Mark Twain or someone else and try this again. Ready, set, go. All right, so this is the way I go about that. Let me get some more novels here. Yeah, this one's much more involved. Okay. Let's take a look how I would approach this one. So I went ahead and just used Mark Twain. I had Mark Twain on hand from a previous course. You could get more right from the Project Gutenberg. So I got 4 novels by Mark Twain. I got Connecticut Yankee, I think that is. Yeah, Connecticut Yankee. I got Huck Finn, Prince and Pauper, and Tom Sawyer from by Mark Twain in a different directory, right? Over here in Mark Twain, next near Jane Austen. Okay, so I got those TXT files from Project Gutenberg. And so my path right there is simply a string that I put into that variable, right? And then I say, okay, look in there and give me the file name. So I want all the Austen file names. And I'm doing an OS path join, which means take this string, which has the pathway down to the Jane Austen directory, and append it with the current file, TXT file in there. So that's what that does. OS list dir is giving me what's in the directory, this current directory right there, my path. And I say if it ends in TXT, this is dealing with other files that may be in the directory, whether they're visible or not to us. There's some, computers have some files in directories that are hidden. And anyway, it could cause problems if you don't do this. Only give me files that end in TXT. So that gives me all the Austen files. And then I do the same thing with the Mark Twain directory. That gives me all the Mark Twain files. And if I print these out, let me just print these out for you. I'll print out right here, print Austen files. And then right below Twain, I'll do print Twain files. Okay. Let me pause the video for a second. I want to figure out how to raise an exception. One quick second. Okay, so I'm just going to walk through this code step by step. So what I'm doing here is I'm just saying, okay, get the Austen files and then print them out to me so I can see that you got them correctly. Get the Twain files and print them out to me. And then here I raised an exception on purpose to stop the script so it doesn't worry about doing the rest of it, which is time consuming. And when I run it, it does it. So I'll just run it again so you can see. So it prints out the file names as lists. So one list are the Austin files up to here. You can see the square brackets right there and right there, right? And the next one are the Twain files right there in a list, right? And then that just stops the script so I can kind of work through it step by step. All right, the next what we do is we create a single list with file names for both directories. So we create an empty list with square brackets. We extend the Austin files onto that list, and then we extend the Twain files onto that list. And so I can just print out those for us if we want. I'll just print this out. Print file names, please. Run the whole script. And we have a big long list with both Austin and Twain files together. You can see Tom Sawyer's right next to Pride and Prejudice in the same list. Okay, good. We have an output file there. We're going to open up a connection to that out file, and we're going to say W for write as F out. We're going to write a header like we did previously, separated by tabs, and we have a new line break at the end. Then we're going to loop over each novel in turn, right? And we're going to get our counters, our feature counter and our total word counter. And then we're going to get the author's name. So this right here, line 29 says, if you find Emma, Pride, Sense, Persuasion, North Angler, or Mansfield in the current novel name, that is file name, then the author is Jane Austen. Elif, that is else if, so if that evaluates to false, then it comes down here and says, okay, tell me if you find Huck, Sawyer, Connecticut, or Popper in the novel name, the file name. If that's true, then author should be Mark Twain. Else, if that evaluates to false, then say the author is, no, I'm not sure. That should not run in our simple case here, but anyway, it's useful to have a final else statement that alerts you to some error that you're not expecting. Okay, so we're getting an author. We're identifying the author with the novel. That's one way to do it. We could have done another way by looking at the pathway and just grabbing it off the pathway, but okay. We're going to open up the current novel and increment the counters as appropriate. So with open current novel as fin, file in, we're going to loop over each line. Good. We're going to split up the current line into words like we've done before, the same regex there. We're going to loop over the words, and we're going to deal with empty strings again like we have in the past. We're going to increment the total counts by 1 like we have in the past, where we just want to know the total number of words in the current novel. And then we're going to search for some regex. Our feature, our linguistic feature is this regex right here. In this case, I'll just stick with handsome for the moment, or any of its forms. And if we find a handsome or one of its forms, then increment the count feature counter. So that runs all the way through. I'm going to go ahead and just point out the indentation here again. So this line 47 norm count is lined up with this for loop that begins on 38. So that means that the for loop that begins on 38 will finish running. That means it'll run through all the lines before it comes down to 48 and continues with the script. So we do our simple math. We do not even need those right there, but you can have them there if you want, the parentheses. So take the feature counter, divide by the total word counter, and times it by 1,000. And there we have an output string again, like we did in the past, where we concatenate a string with a tab, plus the author that we created up here, right? Whether Jane Austen, Mark Twain, are not sure. We shouldn't have any not sures, but then a tab, then we have an OS path base name of the novel. Just so we only want the file name. We don't want users, EKB5, documents, link 360, then emma.txt. We just want emma.txt. That's what this base name function is doing there within the OS module there. Then we concatenate another tab. Then we take a string version of this ratio that we just, or this normalized count that we just created. Then we add a new line break to it. That's simply creating the output string. And then we actually write it out to the hard drive, to the out file there on line 49 with fout.write. So once again, fout is the variable name. I gave it right up here on line 21. So it's still open. It has the out file connection open this whole time as it's running through the 6, or now it's 10 novels. 6 from Jane Austen, 4 from Mark Twain. Okay. And that's it. And it finishes it that way. So, you know what we can do? So as like a little progress report, we can have it print out to us which novel it's on when it's working. So within the for loop there, I'll say print the novel, please, so we can see what's happening, where you're at. So I'll run this. And here we go. There, it gave me a list of all the, right here is a list of all the files. Then it just finished Mansfield Park. Now it just finished Sense and Sensibility. Just finished North Anglia Abbey, Persuasion, Emma. Now it's working on Pride and Prejudice. Now it's just finished Tom Sawyer Quickly. And it's going through all these things. Boom, done. Exit code 0, good. That means everything was successful. So now let's double check my output file. I called it, within the downloads directory, I called it results.csv. Let me double check it's not open over there. Good, I don't want it open over there. But actually, let me import it over here. So I'm going to do a new file or a new workbook thing. Go up to data, from text, find my results. And next, tab, yep, tab, finish. Put it A1, that'd be fine. Okay, let's zoom in here. Okay, so yeah, we're looking for handsome and other words like handsome, that is forms of handsome. And what do we see here? In the Jane Austen novels, these first 6 lines, right? This column right here shows the Jane Austen novels. What do we see? We see 0.2 is the lowest and 0.4 is the highest per 1,000 words. Okay. And looking at the Mark Twain 4 novels that we got from Mark Twain, the highest rate of handsome or one of its forms is only 0.09. So less than half as frequent as the lowest use in Jane Austen. So we could say, yeah, Jane Austen uses handsome or one of its forms much more than twice as much on the low end in comparison to Mark Twain, on Mark Twain's high end of 0.09, right? 0.09 is less than half of 0.2. Okay, so that, yeah, we can compare here because we normalize the counts. Good. So once again, we have to normalize the counts in order to compare like that. We can't just look at raw counts because the total number of words would be different for each one of these novels. So I'd recommend you look at the solution file and work through the solution file, make it work on your end. I added some print statements in here just for us to see what it was doing and as it was working through the script. Okay, let's see one more to go here with this idea of normalizing counts. It says modify your program to get normalized counts for each author, 2 normalized counts, 1 per author. Again, modify the code that produces the output CSV file to make it easy to compare. Okay, so rather than doing it by novel, right? So over here, we were normalizing to each novel, right? We got a value for Mansfield Park. We got a separate value for Sense and Sensibility, etc. Right? Separate value for Tom Sawyer. So rather than doing that, just normalize it to, or just get one number for Jane Austen and another number for Mark Twain. So your CSV file will only have 3 rows. First row is a header, feature, author. You don't need novel here, right? And then row 2 would be the number for Jane Austen, and row 3 would be the number for Mark Twain. Okay. So see if you can do that. Modify your program and see if you can get normalized counts for each author. Just 2 normalized counts, 1 per author. Okay. Pause the video and give that a try. Okay, let's take a look. Welcome back. Let's all right, this gets a little more involved. So like I say here, I put the bulk of the previous program in a function so I can call it several times in order to not repeat myself. So don't repeat yourself. You shouldn't, if you find yourself ever copying and pasting chunks of code, you should stop and try and put it into a for loop or put it into a function that you can call repeatedly. So this says get norm count. I give it a pathway and I give it a regex, and it outputs, like I say here, takes as input two strings, one indicating the pathway to a directory with txt files. The second is a regex to get the normalized count for within all txt files in the directory. Okay, we import RE as well as OS. You can separate those by commas, or you can write a new statement. You could write a new statement like this if you want as well. Either way, I think you're supposed to do on separate lines like this, but I don't really care what the code looks like as long as it works and you have comments in there and it's efficient and you don't repeat yourself. Anyway, so we get the file names again of the current directory that we passed into the function there. Just give me the file names. So if I pass in the Jane Austen directory, it'll give me 6 file names, right? If I pass in the Mark Twain, it'll give me 4. Again, we have 2 counters here, like we have in the past. We loop over the file names. Novel, right, is the variable name that we'll use in here. We use it right there on 18. We open up a connection to the current novel. Say that connection is fin. Loop over each line in that current file. And then we split up on words. This is all the same from before. We loop over the words, make sure that there's something in the current element. It's not an empty element, which can happen. We increment the total counter. We search for the regex that we pass in to the function call right up here, right? It comes in as an argument right there. And we use it right here. And then we increment the feature counter if we find that the current word has that regex. This is all from what we've seen now a couple times. And then we get a norm count like that. Again, right, the feature count divided by the total count times 1,000. And then we just return that number out of the function. So we just say that to a variable, return it out of the function. And now we know the function definition is ended because the indentation now goes to the far left. Okay, so here is my regex, R, open, double quote, handsome. That same regex we've seen several times now. So here is Austen count. And so I call the function get norm count, which I just defined. I'll just jump back up and show you. That's what I called it. Get norm count is the function name that starts on, that's defined on line 4. And the function definition ends on line 28. I pass in the directory, the pathway to the directory with Jane Austen novels, and I pass the regex right here. And then I do the same thing with the Mark Twain directory here. So I say, okay, now go do the same thing in the Mark Twain directory. And I say those as 2 different variables, Austen count, Twain count. And then so that run, those run. And then on line 35, I open up an out file, same name, results CSV, you can call it whatever you want. I write a header, and then I write out the Austen count, right? Handsome and derived forms, Austen, then I push to string the Austen count. Then I write another line, same thing, Mark Twain, string Twain count. Okay, if we want to see what's going on here, we could actually go ahead and print out a little progress report. Print novel like that, just so we can see that it's working and hasn't errored out, it hasn't frozen or anything. All right, so I'm going to run this and let's watch the magic happen. It's working on Mansfield Park. Now it's working on Sense and Sensibility. Now it's gone to, it's going pretty quick. You can see it's running pretty quickly. Pride and Prejudice, now we're done. Tom Sawyer, Connecticut Yankee, Prince Popper, Huck Finn, boom, done. So I went through those 10 novels in that amount of time. And let's take a look. So let's import our CSV file. This step is onerously not quick. Now I could make it quicker. I should point out that I could and probably should use a comma right here rather than a tab. You can use a comma. I'll show you. I'll do so. I'll call an audible here and change these to commas rather than tabs. So all I'm doing is changing the \T, which represents tab in computer speak, to a comma. And let me rerun it. It'll be pretty quick, but let me rerun it. And it'll make this easier to import this into here. I'll just be able to double click on the results.csv file that should import correctly into Excel. Well, no, I have another spreadsheet as my default application for CSV files. So there it's done. So I'm going to come over here, go into my downloads folder, go to results, look at the modification time, which is this very moment right now. I'm going to grab this and drop it right on top of Excel, and it should hopefully just go all the way in by itself. Yeah. Okay, so what do we see here? Yeah, as we expect, as we hypothesized, Jane Austen uses handsome or one of its forms much more frequently than Mark Twain. We could do division right here, right? We could say, okay, well, how much is that? Let's do equal sign C2 divided by C3. So Jane Austen uses handsome or one of its forms, handsomely, handsomest, etc., 4.5 times more frequently than Mark Twain does in his novels. That's exactly what I'd expect. Right. So there you have it. Let's try something else. Let me try another regex. Let me jump up to the regex area where I define the regex. Oh yeah, I pass it into the function right here. So rather than handsome, let's try something like, I don't know, river. I bet river occurs more in Mark Twain. So river \B to make word boundaries right. \B is word boundary river. So in this case, we're not looking for handsome or one of its forms. So I'll just change that just to make sure it's clear. We're looking for river. We're looking for the exact word river. Okay, I'll run this script now again. Take a few seconds to get through it. I'll just shut that down for the moment. I don't want to save that. It's working on Emma, Pride and Prejudice, Tom Sawyer, Connecticut Yankee, Prince and Popper, Huck Finn. Done. And this just, I'll drag this and drop it right on top of this. And what do we see? Yep, as we expected. Mark Twain uses the word river more often in his novels than Jane Austen does. We can take a look at that. If we do equal sign C3, which is the Mark Twain number, divided by C2, which is the Jane Austen number. Whoa, 35, almost 35.5 times more frequent. We see river in Mark Twain's novels than we do in Jane Austen's novels when we normalize those counts to a base of 1,000 words. That's what we'd expect. He talks about rivers, Mississippi River, Huck Finn, having a good time on a raft on the Mississippi River, right? Okay, so there we go. There we go. That is how you normalize counts, and this is important. So like I mentioned again with the rationale, you have to do this if you want to compare numbers between books or corpora, because you cannot assume that the books, or the novels, or the corpora are the exact same number of words. They're likely not the exact same number of words. So you have to normalize those to some common base, like 1,000 words or 1,000,000 words. Okay, so that is how you normalize counts, and that is important for several of the homework assignments in this class. And that is it for lesson 5.3. Have a good evening. See you next time.